How did scientists discover Earth's age when no one was there to witness its birth? When nobody knew the answer, here's a question that sounds surprisingly simple, yet it has puzzled humanity for centuries. How old is the Earth? Today, scientists answer with confidence about 4.54 billion years. But where did that number come from? There were no humans, no animals, not even a single living cell. Life itself hadn't begun. So how could anyone determine the age of an event that happened billions of years ago when there wasn't a single witness? Even more astonishing, how did scientists arrive at such a precise number instead of making a rough guess? The mystery begins. If you want to know the age of a house, you check its construction records. If you want to know the age of a tree, you count its growth rings. But how do you determine the age of an entire planet? Earth doesn't come with a birth certificate. There is no historical record telling us when it formed. All we see today are mountains, rocks, oceans, and continents. Could these silent landscapes possibly tell the story of something that happened more than 4 billion years ago? That's exactly what scientists set out to discover. And the journey was anything but easy. When Earth's age was just a guess, for thousands of years, humanity had no scientific way to measure Earth's age. Most civilizations relied on myths, legends, or religious traditions to explain the world's beginning. In Europe, during the 16th and 17th centuries, several scholars attempted to calculate Earth's age using biblical genealogies. The most famous was the Irish Archbishop James Hutton. After years of study, he concluded that Earth was created in 4004 BC. He even proposed the exact season, October. Today, that conclusion sounds surprising, but at the time it was considered a serious scholarly effort, simply because science had no better tools. As a result, many people believed Earth was only about 6,000 years old. But nature itself was quietly telling a different story when the rocks began to speak. The more scientists studied mountains, the more impossible questions emerged. How did this canyon become so deep? How long did this river need to carve solid rock? How did thousands of layers of sediment accumulate over one another? None of these processes could have happened within just a few thousand years. Then came a Scottish scientist who completely changed the way people thought. His name was James Hutton. Standing before ancient rock formations, he proposed a revolutionary idea. The Earth changes incredibly slowly, but it never stops changing. The rain falling today, the wind blowing right now, the rivers flowing before our eyes are the very same forces that have shaped mountains and continents over unimaginable spans of time. For the first time, scientists began speaking about a concept known today as deep time. The history of our planet wasn't measured in thousands of years, but in millions, perhaps even billions. But one enormous question remained. Exactly how old is it? The first scientific attempt toward the end of the 19th century. One of the world's greatest physicists believed he had the answer. His name was Lord Kelvin. He trusted the laws of physics, and his reasoning seemed perfectly logical. He proposed that Earth began as a molten ball of rock. If that's true, then it must have gradually cooled over time. By measuring Earth's current temperature and applying the physics of heat transfer, he believed it was possible to calculate how long that cooling process had taken. After years of calculations, Lord Kelvin announced a remarkable result. He estimated Earth's age to be somewhere between 20 and 100 million years at the time. This was considered one of the greatest scientific achievements of the century, but there was one crucial problem. One discovery had not yet been made, and without it, his calculations were doomed to fail. The discovery that changed everything. In 1896, French physicist Henri Becquerel made an unexpected discovery while studying uranium salts. Some elements, without any heat, without any light, and without any external source of energy, were releasing energy all by themselves. Years later, scientists realized they had discovered something extraordinary: radioactivity. Even more surprising, radioactive elements buried deep inside Earth constantly generate heat. That meant our planet wasn't simply cooling down, as Lord Kelvin had assumed. Instead, Earth has its own internal heat source. His calculations collapsed overnight. But at the same time, this discovery opened an entirely new door, a door that would eventually allow scientists, for the very first time, to determine Earth's true age. But here's the real question. How can invisible atoms become clocks capable of measuring billions of years? That's the mystery we'll uncover in Part 2.